what is momentum? Momentum is symbolized by the letter P and is simply the product of the mass and the velocity, measured in kilograms meters per second. The greater the mass or velocity, the greater the momentum is going to be. Momentum is related to Newton's first law of motion, which is inertia. Let's look at a simple question to better understand this concept. A biker and his bike have a combined mass of 90 kilograms and is moving at 10 meters a second. We only have to multiply the mass and the velocity, which would give us a momentum of 900 kilograms meters a second. In a closed system, momentum can neither be added nor removed. What is a closed system? A closed system is a system where the objects cannot be influenced by external forces. That means that the total momentum before and after a collision must be the same. Let's look at another example. Say a biker and his bike have a mass of 90 kilograms and are moving at 10 meters a second. Suddenly, his friend tosses him a bag with a mass of 5 kilograms, which he catches. In order for his momentum to remain equal, his velocity must reduce, since his mass has been increased. This is exactly what we see in this video. So given the formula for momentum, let us try to calculate his velocity after the collision. Let's start with an equation for conservation of momentum. So on the left of our equation we have 900 kilograms meters a second. Let's say this is heading north. On the left side we have the mass and the velocity. But we want to know what the velocity is because we're now increasing the mass. So in the brackets there we would have 90 kilograms plus 5 kilograms. And then in the second line we would move the 95 kilograms onto the bottom, and we would have 900 kilograms meters a second divided by 95 kilos, and that would give us our final velocity. And of course we have to round it to 2 sig figs, so the biker's velocity in the end at the collision after he's caught the bag would be 9.5 meters a second north. In order to change an object's momentum, we have to apply a force to it. The product of force and time is impulse, which is simply the change in momentum and is measured in newtons a second. However, you might ask that if momentum is measured in kilograms meters a second and impulse is measured in newtons a second, how can the two be the same? Well, if you remember back in the previous forces unit, a newton is a kilogram meters a second squared. With some simple algebra, we can see that a newton second and a kilogram meter second are really the same thing. In physics, there are two types of collisions. The first type of collision is an inelastic collision. In an inelastic collision, the two objects become one mass and kinetic energy is lost. The second type of collision is an elastic collision. In a perfect elastic collision, 100% of the kinetic energy is retained. This usually requires the objects in the collision to have the same mass. First, let's look at an inelastic collision, as it will help us show an example of impulse as well. An 80 kilogram rugby bat running at 5 meters a second is tackled by a 160 kilogram prop, running in the opposite direction with the same speed. What would be the bat's velocity after the collision, and what would be the impulse he experienced? Let's set up the equation to find his velocity first. We have the inelastic collision equation. We have the 80 kilograms of the rugby back player multiplied by his velocity, which is 5 meters a second, and then we add it on top of the prop's 160 kilograms, and he's heading 5 meters a second in the opposite direction, so you would have negative 5 meters a second. On the right side of the equation, we want to find the velocity, but we already know the mass of the two combined, which is 240 kilograms. So just like in previous equations, we move the 240 down to the other side, which means you have to divide that entire side of the equation. And so the result would be 400 kilograms meters a second minus 800 kilograms meters a second. And then you take that entire thing and divide it by 240 kilograms, which will give you a velocity of negative 1.66 meters a second repeating. And we round that to 3 sig figs, which would be negative 1.67 meters a second. Now, once we have found the velocity of the two masses after the collision, we can find out the impulse experienced by the rugby back. So we simply take 80 kilograms and then we can put that in a bracket, and then take a second set of brackets, put negative 1.67 meters a second, because that's the second velocity, and then you minus the initial velocity, which should be 5 meters a second. And the resulting answer would be negative 553 Newton seconds of impulse. Once we have found his velocity after the collision, we can calculate the impulse he experienced. Finally, let's take a look at an elastic collision. In this case, we have two air hockey pucks undergoing a collision. Notice how after the collision, the first puck has lost all of its speed and has been transferred into the second puck. The velocity can be calculated using the law of conservation of momentum formulas. Finally, we have our elastic collision example. So, say a 0.1 kilogram air hockey puck is moving at 10 meters a second, and it strikes another air hockey puck, which is stationary with the same mass. And you want to know what velocity it has after the collision. You simply set it up like this. You have 0.1 kilograms multiplied by 10 meters a second on the left side of the equation, and then you have 0.1 kilograms on the right side of the equation, and we don't know the velocity yet, that's what we want to find out. And then, just like all the rest of our equations, we move the mass back to the other side by dividing the entire side, which would give us, of course, 10 meters a second. And we know this because we have the law of conservation of momentum, which states you can't add or remove momentum. So it makes sense that our numbers are the same. And so this concludes our physics video. We hope you guys enjoyed it, and hopefully it taught you a little bit more about momentum before Powell drops his test on us. See you guys next time, and good luck.